Hello and welcome to A-Level Math. Today's topic is about relations. This topic assumes that you have already seen the videos that are uploaded in this series about sets because understanding of sets is a prerequisite for understanding any concepts that we will be going to discover in this video. So, before understanding what relations are, let's first understand what we mean by Cartesian products. So assume that we are given two sets. The first set is 0, 2 and 5 and set B is 2, comma 4. A Cartesian product is a set of ordered pairs where each element of that order pair come from these two sets. So the Cartesian product of these two sets A and B is denoted as A cross B, and we'll be writing down the Cartesian product as 0 comma 2, this is our first pair, 0 comma 4, this is our second pair, 2 comma 2, this is our third pair, 2 comma 4, 5 comma 2, and finally 5 comma 4. So these are the elements present in the Cartesian product of A and B. Notice that the first element of each of these Cartesian product comes from A, whereas the second element from each of these ordered pairs come from the set B. So we can also write this set as the set of all those pairs A comma B such that A belongs to A and B belongs to B. Remember that the order of these ordered pairs is important. So when I say that the order is important, that means that any particular ordered pair, say for example 5 comma 2, cannot be written as 2 comma 5. This cannot be done. So this order 5 comma 2 or 5 comma 4, this order is important. That is why each of this pair is called as an ordered pair. So can you tell me how many elements are there in this Cartesian product of the sets A and B? So there are in all 6 elements, right? 1, 2, 3, 4, 5 and 6. So this is quite obvious because A is having 3 elements and B is having 2 elements. So the total number of elements will be 3 times 2. If you are familiar with permutations, then the total number of these ordered pairs would be the number of elements that we can take from A, which is 3, times the number of elements that we can take from B, which is 2. So this is 3 times 2, which is 6. You will be getting a more understanding of it about the number of all those ordered pairs when you are through with the chapter permutations. Okay, so let's take up an example. If P is equal to A comma B and Q is equal to X, Y, Z, then show that P cross Q is not equal to Q cross P. So when we have to write down P cross Q, we have to make sure that in this Cartesian product, the ordered pairs will have its first element from P and second element from Q. So the elements would look something like this: A comma X, A comma Y, A comma Z, B comma X, B comma Y, and B comma Z. And if we write down Q cross P, then the ordered pairs will switch their positions like so. The first element will be an element from Q and the second element will be an element from P. So the elements would be Q comma A, X comma A, X comma B, X Y comma A, Y comma B, Z comma A, and Z comma B. So that is why P cross Q is not equal to Q cross P. So that means that the Cartesian product is non-commutative with respect to sets. Okay, let's take one more question. A and B are two sets given in such a way that A cross B contains six elements. So it is given that in all the Cartesian product has six ordered pairs. So it contains six elements, that means six pairs are there. If three elements of A cross B are these, and this, then find its remaining elements. Okay, so we are given three elements from A cross B, and we know that in all there are six elements. So we have to find out all the elements. So it is not that difficult because you see, we know that these first elements are coming from A. So A will look something like this. It might have some more elements over here, so I'm keeping a space so that if we find out some more elements, we can add them later. But one thing is for sure, that these left hand side parts of the numbers are surely there in A, and similarly the right hand side part of these pairs are surely there in B. And we are not repeating, so 3 5 and not 3 again, so I'm keeping again some more numbers over here, so that if we find that there could be more numbers, then we can add it later. But now you see that it says the total number of elements is 6, and we know that if this is the case, that if A is equal to this and B is equal to this, then there are already 3 times 6 elements. That means there can be no more elements in A and no more elements in B, because if 3 elements are there in A and B has 2 elements, then as of now we are already having 6 elements, right? So that means these are all the elements of A and B. There are nothing more than that. So we can write down the remaining ordered pairs. So before that, let's just write down all of the ordered pairs, and then we'll keep only those that are not already given. So 1 comma 3, 1 comma 5, 2 comma 3, 2 comma 5. I'm writing down all the ordered pairs, 3 comma 3 and 3 comma 5. So these are all the ordered pairs. So out of these we are given 1 comma 3, 2 comma 5 and 3 comma 3. So the remaining 3 ordered pairs are these. Okay, A is given to be 2 comma 3, B is given to be 4 comma 5. Find A cross B. So let's quickly write down what is A cross B. You try it on your own. 2 comma 4, 2 comma 5, 3 comma 4 and 3 comma 5. So this is how our A cross B looks like. How many subsets will A cross B have? So remember the concept of power sets that we discussed in sets. So it is just asking the same thing. How many subsets can you form from this given set? So we already know that the total number of subsets that can be formed from a given set with n elements is 2 to the power of n. So here we are having n is equal to 4 because there are 4 elements in this set. Remember that each ordered pair is an element of the set, so there are actually 4 elements. So there are 4 elements, so we can form 2 to the power of 4, which is 16 subsets from this Cartesian product A cross B. Okay. If A is a subset of B, then prove that A cross C is a subset of B cross C for any set C. So let's try to understand this with the help of an example. So you just take two sets of your choice where A is a subset of B. So say for example, if you take A as 1 comma 3, then you have to take B as 1, 3 and plus some more elements of your choice. Say for example 7. You could have taken anything. This is just an arbitrary choice. But make sure that A is a subset of B, which here it clearly is. Then prove that A cross C is a subset of B cross C. So you can take C of your choice, any set of your choice. Say for example, we take C as 0 comma 1. Okay, so what is A cross C? A cross C is 1 comma 0 and 1 comma 1. And what is B cross C? B cross C is 1 comma 0, 1 comma 1. I'm sorry, there are two more elements in A cross C, 3 comma 0 and 3 comma 1. And in B cross C we have 1 comma 0, 1 comma 1, 3 comma 0, 3 comma 1 and 7 comma 0 and 7 comma 1. So these are the elements in B cross C. So clearly A cross C is a subset of B cross C because all these elements 1 comma 0, 1 comma 1, 3 comma 0 and 3 comma 1 are already there in B cross C. It's just that B cross C is having these two extra elements. So A cross C is a subset of B cross C, and this is quite intuitive as well. So because you can see that all of these elements has to be there in B cross C, except that 7 comma these elements 7 comma 0 and 7 comma 1 will be added on. Okay, so graphical representation of a Cartesian product. So assume that I am given some Cartesian product as A cross B is equal to 2 comma 1, 3 comma 5, 1 comma 2 and 5 comma 9, and there could be some more elements as well. I'm not writing down them all of them. So suppose that here is your set A and here is your set B. So what are the elements of A? The first element is 2, second element is 3, 1, 5. There could be more. I haven't written down all of these elements. So these are the elements that are there in A for sure. Similarly, there are some elements in B, 1, 5, 2, 9 and there could be more. So we say that 2 is going to 1, 3 is going to 5, 1 is going to 2 and 5 is going to 9. This is just the graphical representation of ordered pairs. So if you can think of an ordered pair, then you might have come across with the coordinate geometry, the number system in the coordinate geometry. The ordered pairs work exactly the same way. Just like in coordinate geometry, any point, say for example, the point 3 comma 2 is not the same as the point 2 comma 3 because these two have different locations. So that is the same case with ordered pairs. You cannot switch the position of these numbers. 3 comma 2 is not equal to 2 comma 3 because they are located on different points of the Cartesian system. So this is an example you can think of as an ordered pairs. Let R be the set of all real numbers. Then what does R cross R represent? So suppose this is the real line. We are having 0, 1, 2 and all the numbers over here and negative numbers over here, and assume that this is also the real line. So we are also having 0, 1, 2 and so on and so forth in both the directions. So what do you think this entire plane R cross R will be? R cross R will be this entire plane, right? Because you are taking the Cartesian product of this entire set. So you'll be getting all of these points. You'll have to cross all of them. So you'll be getting all of these points, which is nothing but the R squared plane or the Cartesian plane. This is the two-dimensional plane of the real numbers, the Cartesian system. And similarly, if you are given the set of real numbers as R, then R cross R represents a three-dimensional space. Okay, so R cross R represents a two-dimensional space and R cross R represents a three-dimensional space where each axis is having real numbers. Now let's come to the main topic of this chapter, which is relations. So as of now we have just discussed what Cartesian products are. Now relations are defined as any subset of a Cartesian product. So if you are given a Cartesian product of A and B, then there are many ordered pairs. You can take any number of those ordered pairs of your choice. So say for example, if we are having A cross B as 1 comma 4, 1 comma 5, 2 comma 3 and 2 comma 5, then a relation can be defined as 1 comma 4 and 2 comma 3. Any number of elements of your choice will be called as a relation. So a relation is any subset of a Cartesian product. That is the definition of a relation. So let A and B be two non-empty sets. The requirement is that both of these sets A and B should be having some elements in them. They cannot be empty. Then a relation then a relation R from A to B is a subset of A cross B. So you do A cross B, you find out the Cartesian product, and then you take any subset of that Cartesian product. That will give you a relation. So can you tell me, for any two sets A and B, how many relations we can define? So assume that there are two sets A and B given as this. Then can you tell me how many relations can be formed from these two sets? Okay, that's quite easy because we know that relation is any subset. So you just have to tell me how many subsets can be formed from its Cartesian product. So we know that A is having 3 elements. So NA is equal to 3 and NB is equal to 2. That means B is having 2 elements. So A cross B will have 6 elements. We have already seen this result. So the number of elements in A cross B is 6, and A cross B is having 6 elements. So how many subsets you can make from A cross B? We have already discussed that. That's the number of elements in the power set. So it is 2 to the power of 6, which is equal to, I guess, 4, 8, 60, 32 and 64. So that is 64. There can be 64 relations that you can define on your own from these two given sets. Okay, let A be equal to 3 comma 5 and B is equal to 7 comma 9, and let R be a relation of all those A B where A belongs to A and B belongs to B, and A minus B is odd. So show that R is an empty relation. Okay, so let's just try to write down A cross B first. A cross B is 3 comma 7, 3 comma 9, 5 comma 7 and 5 comma 9. So now we have to we are given R such that all those pairs A and B, such that A minus B is odd. So out of these pairs, you just have to take those pairs which satisfy this relation, that A minus B is odd. So 3 minus 7, is 3 minus 7 odd? 3 minus 7 is minus 4, which is clearly not odd, which is even. So 3 minus 7 cannot be taken. Similarly, 3 minus 9, which is minus 6, is even, so it cannot be taken. 5 minus 7 is minus 2, which is even, and 5 minus 9, which is minus 4 again, is even. So none of these numbers, none of these differences are odd. So there is simply no element inside R. So that means R is an empty set. That means R is an empty relation from A to B. Okay. Now let's cover the concept of domain, range and codomain. Try to understand this concept really well because this will be used even further in the chapter functions. So let's understand this with the help of an example. You are given two sets, set A and set B, and you are given a relation. So first of all, we have to verify whether R is actually a relation from A to B or not. So in order to verify that, we just have to make sure that R is a subset of A cross B, and that is it. If you can show that all of the elements in R are there in A cross B, then that means that R is a subset of A cross B and it is a valid relation from A to B, because that's what the definition says. R has to be just a subset. Any subset will work, but it has to be a subset. So what is A cross B? A cross B is something bigger, so we are not writing it down over here. Let's just verify whether each of the elements in R is also an element of A cross B or not. So minus 2 comma 4. Minus 2 comma 4 So we have minus 2 in A and 4 in B. So minus 2 comma 4 has to be there in A cross B, right? Similarly, minus 1 comma 1. Minus 1 is there in A and 1 is there in B. So minus 1 comma 1 will be there in A cross B. 0 comma 0, 0 is there in A, 0 is there in B. So 0 comma 0 will be there in A cross B. Similarly, 1, 1 comma 1, and finally 2 comma 4. So all of these elements are there, means whatever the elements are there in R, they are all there in A cross B as well. So R is a valid relation from A to B. So the first part is done. Now we have to find out the domain, range and codomain of R. Okay, so let me define what a domain is. Domain is the set of all these first numbers that you find in these pairs. This is the domain of R. You forget about A and B now. You have an R, you take only the first elements that are there. So the domain of R are only the first elements of ordered pairs. So minus 2, minus 1, 1 and 2. This is the domain of R. The codomain of R is similarly the right hand side parts. Okay, so codomain is, okay, let's first understand range. Range is the right hand side part elements of R. So range of R is the right hand side part elements of R. So range is 4 comma 1 comma 0 comma 1 comma 4. This is what range is. So domain is the left hand side parts and range is the right hand side part. So what is codomain? Codomain is simply the set B, the right hand side. So if these elements are from B, then the entire set B is called the codomain. So make sure you're not writing down codomain as A, because all those elements from the left hand side part are domain, the right hand side part in this relation are range, and all of the elements in the set B, that means the set which comprise of these right hand side part elements, form the codomain of R. Okay, so that's it. Let's have a recap of what we did today. We understood the concepts of Cartesian products. We understood how many subsets can be formed from Cartesian products. Then we defined relations, and we saw how many relations can be formed from one set to another. So thanks a lot. I will request you to study hard and go through the examples, and just try to understand those examples on your own, and then take up the exercises. Study hard, study smart. All the best. Bye bye. Take care.